This is Pre-Calculus Section 7.1, Part 2, Vertical Parabolas. The definition of parabola is this. It is a set of all points in a plane equidistant from a fixed point and a fixed line. This is the fixed point called the focus. This down here is the fixed line called the directrix. So again, it is a set of all points in a plane equidistant from the fixed point and a fixed line. And what that means is if I draw from the focus to a point here, then that is equidistant from that same point down to the directrix for any point on the parabola. If I go over here and I go straight down, then those are equidistant. Now, we have seen before this formula, y equals ax squared. We had that in college algebra. This new form has got the x squared by itself, and it's got this coefficient over here, 4cy. So we need to talk about the relationship between these forms because you may at some point see the coefficient here instead of over here. This is the form we want to use now. So the relationship between these two forms is this. If I bring this over and I put x squared right here and I put 4cy right here, then if I want to take what's written in red and solve it for y, I would need to divide both sides by 4c. I'm going to put a little 1 in front here, and what that tells me is that a is equal to 1 over 4c. It also means that c is equal to 1 over 4a, and how I would get that would be to cross multiply and solve that for c. So standard form for the vertical parabola with vertex hk is this right here. X minus h squared equals 4c times parentheses y minus k. The vertex is hk, h is with x, k is with y. Nice and convenient. It is alphabetical order. X comes before y, h comes before k. Also, we need to change the sign just like we did with circles. The axis of symmetry is the line x equals h. So if you can get the vertex, you automatically have the axis. The axis of symmetry is x equals h. For a vertical parabola, your axis of symmetry is a vertical line. Vertical parabola, vertical line. Your focus, which was this point in here, your focus is this point right here. Your focus is h comma k plus c. Now what is c? C is this distance right in here, or right in here. C is the distance. Actually, the absolute value of c is the distance from the vertex to the focus, or from the vertex down to the directrix. So if this is a distance of 2, then this is a distance of 2. The directrix, which is this line down here, is y equals k minus c. Notice for the vertical parabola, we are doing something to the k value, which is the vertical part of your vertex. We add to get the focus, we subtract to get the directrix. Now here's a little conclusion of some of the things I've just discussed here. You may see the form in this, you may see this, or you may see this, and all of those indicate we have a vertical parabola. You can think about it one of two ways. You can think about when you see x squared, that makes a vertical parabola. The other way is if x is squared, that means y is not, and what you see in y right there is a vertical parabola. So that might be a way to help remember which is which, because we will look at horizontal parabolas in a little bit. So already said c, absolute value c, is the distance from the vertex to the focus, or the distance from the vertex to the directrix. And if c is greater than 0, the parabola opens up, and if c is less than 0, the parabola opens down. So if you had 8y equals x squared, that's a positive number, this opens up. But if you had negative 12y equals x squared, that's a negative number, and that's going to be upside down. Also, the focus is inside the parabola, and the directrix is outside the parabola. And I mentioned this already, a vertical parabola has c added or subtracted from k to find the focus and directrix. To find the focus, you add, k plus 0. To find the directrix, you subtract. So let's look at some examples. Find the vertex, focus, directrix, and axis of each of these parabolas. So x squared equals 8y. As soon as I see that, I know it is a vertical parabola. I know that this right here is going to help me find c. If that's 8, remember that's standing for 4c. So 4c equals 8, and c is 2. So I do that early on before I do the vertex and axis, etc. You can do it in whatever order you want. So C is 2. The vertex, because I have no parentheses around x or y, the vertex is just 0, 0, which means the axis of symmetry is x equals 0. Remember, the axis of symmetry comes directly from your vertex. Now, to get the focus, you can use the formulas, but that's a whole lot of memorizing. I like to do this by picture form and think about where is the focus, where is the directrix. I know that this is my vertex. I also know that this opens up because this is a positive number. So just make it a sloppy little sketch. I know my parabola looks something like this. I know that my focus is inside here. To get from the vertex to that point there, I'm going up, which means I'm adding C. So my focus is 0, 0, which is where I started, plus C, which just gives me 0C, which is 2. My directrix is down here at a distance of 2. To go from 0 down to 2, I get the directrix of y equals -2. Same set of directions, and notice right off the bat that this coefficient right here is negative. That means that this parabola will be upside down. The other thing you'll notice is that there are no parentheses with x and y, which makes our vertex 0, 0. And the axis of symmetry is x equals 0. Now to find C, I will take this number right here, this coefficient in front of y, and remember we're always looking for the coefficient in front of the non-squared item. Bring this down, and we're looking at 4c equals -1/2. Get c alone by dividing both sides by 4, and we get c equals -1/8. And if you're no good with fractions, let your calculator do this. Type in -1/2 divided by 4. With the graphing calculator then, hit math, frac, it will give you the fraction -1/8. So I'm going to go here for a little picture to get started. So there's my vertex. I know it's upside down, so I know it looks something like this. We also know that the focus is inside the parabola, and it's a distance of 1/8 away from the vertex. It's a distance of 1/8 units away. Now, I'm ignoring the negative. The way I'm doing it from a reasoning standpoint. Then I'll come back and show you with the formula, and then you choose what you want. From a reasoning standpoint, the focus will be 0, of course, because it's a vertical parabola. The x part of the vertex does not change. I'm going down 1/8, so that will land at -1/8. From the formula standpoint, it is h, k plus c. So h stays the same, k was 0, plus -1/8, and that's what accounts for going down the 1/8. So you can think about it with the formula if you want, or you can think about it reasoning like I do. Now your directrix is up here. Your directrix does not intersect the parabola. It's outside of the parabola, and it is at a distance of 1/8 up from the vertex. So it is the line y equals 1/8. From the formula standpoint, it is y equals k minus c. So k was 0 minus c, which is really -1/8, makes it become a +1/8. So if you're going to use the formulas as written, then c is actually -1/8. If you're doing my reasoning way, you just have to look at what direction you're going and go that amount. I went down 1/8, I went up 1/8. I would like to find c first. There's a 1 here in front of there. So c, 4c equals 1. So c is 1/4. The vertex is going to be 3, -8. My axis of symmetry is x equals 3. And be sure you write the axis of symmetry as an equation, x equals 3. To find this other stuff, I'm going to get a sketch going over here. The vertex is over 3 and down 8, somewhere around in here. Because this is a positive number, it opens up. So I know I'm something like this. It could be skinnier, it could be fatter. I'm not really worried about that. I just want to use this to help me find the focus and the directrix. The focus is inside here, and how am I getting there? I'm attaching C, I am adding C to the y part of the vertex. So the focus is 3, -8 plus 1/4. which is what the formula says. I'm just not using the formula per se. I'm trying to do it from a reasoning standpoint. You do need to clean this up. You can use your calculator, and this will give me 3, negative 31/4. Your directrix is below the parabola here, and it is a distance of 1/4 down from the vertex. So your directrix is y equals the negative 8 minus the 1/4, which would be negative 33/4. Now, as you might recall from college algebra, this is another form for this parabola. To find the vertex, we need to think about negative b over 2a. Instead of completing the square or anything like that, do negative b over 2a, where this is a, this is b, this is c. So you're looking at negative of negative 16 is 16 over 2 times 4. So that's 16 over 8, which is 2. So the x part, which is h of my vertex, is 2. Now, to find the y part, all we have to do is stuff 2 into this equation. You can use your calculator or you can do it by hand, and we get 2, 5. Put 2 in for those x's, do the arithmetic, and you get 5, which means the axis is x equals 2. The domain and range I'll do once I get my graph. So the vertex is over 2, up 5. This is a positive number, therefore it opens up. And the domain for a parabola, the domain for a vertical parabola, is negative infinity to infinity. We had that back in college algebra. The range, from your lowest to highest, the least y value is 5 with a square bracket going to infinity. Now, when you do this on MATLAB, it's going to ask you to pick the tool. You will pick the vertical parabola tool because it is x squared. That makes it a vertical parabola. You will have to plot the vertex. We found the vertex. And you will need to find one other point. Pick whatever point you want, but I suggest you pick a number immediately to the left or to the right of the vertex. That's going to keep the number small enough so that it stays on your graph. So since our vertex was at 2, I would do the arithmetic on 1. Plug 1 in for those x's and do your arithmetic, and it comes out to be 1, 9. And that's what you'll plot for MATLAB, and it will connect the dots and make a parabola. Now we're going the other direction. We are writing the equation for the parabola. We did this for circles. We did this in college algebra for lines. We're going to have some information. We're going to use that information to write the equation of the parabola. Now here's the steps I suggest you do. Number 1, I would start sketching a graph because you have to decide if it's a horizontal parabola or vertical. We have not talked about horizontal, but when you get into MATLAB, it'll be all mixed in. So get this graph, a focus of 0, 2, a vertex of 0, 1. That right there, knowing that my focus and my vertex are on a vertical line, I know that my parabola looks something like this. So there's my graph. What kind of parabola is this? It is a vertical parabola. What is the standard form for this kind of parabola? It is x minus h, quantity squared, equals 4c times the quantity y minus k. So I need to find c before I can plug into this. C, remember, is the distance from the vertex up to your focus. So your vertex was at a height of 1, your focus was at a height of 2, so that means c is 1. And all I have to do now is plug into my standard form. So I will have x minus h, which was 0, and I'll clean that up in a minute, equals 4 times c, which is 1, times y minus 1. And to clean this up, that's this next part, my equation will just be x squared equals 4 times the quantity y minus 1.